All right, today we're going to get into something absolutely incredible. We're talking about your body's own personal, built-in 24/7 security force. This is the innate immune system, and it's your first and fastest line of defense. You really have to think of your body as a fortress. And this fortress, as you can see here, is under constant siege. I mean, from every direction, you've got viruses, bacteria, toxins, all of them trying to breach the walls and set up shop. It is a relentless, nonstop battle happening every second of every day. So, how in the world does this fortress defend itself? Well, it has this super sophisticated military with two main branches. Today, we're zeroing in on the first responders, the innate system. These are the soldiers who are always on patrol. Okay, so here are the two main arms of your immune defense. On the left, you've got the innate system. That's our focus today. The key things to know are it's non-specific, meaning it just attacks anything that looks foreign, and it is incredibly fast. On the right, that's the adaptive system. Think of them as your special forces. They're highly specific, they learn, they remember enemies, but they do take a little more time to get going. So let's start at the very beginning of that innate defense. Before any invader even thinks about getting inside, it has to get past the fortress walls first. And this is really the core idea here. Innate immunity is exactly what it sounds like. It's innate. You're born with it. It's like a pre-installed factory default security system that's ready to go from day one. No setup required. Now, this Great Wall we're talking about, it isn't just one simple structure. Oh no. It is a seriously multi-layered defense. You've got physical walls, you've got chemical moats, and you even have biological guards. Each one presents a totally different challenge to any bug trying to get in. And this right here is a perfect illustration of our main physical barrier, the skin. It's so much more than just a covering. See how the cells are packed in so tightly? That creates a layer that's almost impossible to get through. And on top of that, the outer layer is constantly shedding, literally throwing off any microbes that have managed to grab on. It's just an amazing piece of natural engineering. But what happens when the walls are breached? A cut, a scrape, maybe you breathe in a pathogen. Somehow an invader gets through. This is the moment the internal defense system kicks into high gear, and the very first thing it does is sound the alarm. And that alarm system, it's got a name we all recognize: inflammation. Now, we usually think of it as a bad thing, right? The redness, the swelling, the pain. But it's not the problem. It's the solution. It is the body's emergency broadcast system, basically screaming, "We have a breach. All units respond now." And that alarm follows a very specific four-step protocol. First up, initiation, an immune cell that's already on the scene detects the threat. Then, the vascular phase. Blood vessels in the area expand. That's what causes the swelling and redness, to rush in reinforcements. Third, the cellular phase. The call goes out and immune cells are recruited to the site of the battle. And finally, resolution. Once the threat's been dealt with, the body starts to repair all the damage. Now, this is where it gets really, really cool. This slide shows you that cellular phase in action. Look at this. The immune cells, these leukocytes, are just cruising along in the bloodstream, but then they get these chemical signals, a distress call from the site of infection. They immediately stick to the vessel wall, squeeze right through it, and follow that chemical trail straight to the heart of the action. It's an incredible guided missile system. So who are these cells that answer the alarm bell? Well, let's meet the frontline soldiers of the innate immune system. Their primary job can be summed up in one awesome word: phagocytosis. It literally means cell eating. These specialized cells, called phagocytes, are basically the cleanup crew. Their mission is simple: find the enemy, swallow it whole, and digest it completely. And this slide just perfectly illustrates that process. The phagocyte latches onto the microbe, engulfs it completely inside a little bubble, and then it fuses that bubble with sacs of what are basically digestive acids to just tear the invader to pieces. It's simple, brutal, and unbelievably effective. Now, phagocytes are great for enemies that are floating around outside our cells. But what if the bad guy has already gotten inside one of your own cells? That's when a different kind of soldier steps up: the natural killer cell, or NK cell. These guys are assassins. They patrol your body looking for your own cells that have gone rogue. Cells infected with a virus or cells that have turned cancerous. They are an absolutely crucial defense against these internal threats. So we've had walls, alarms, and frontline soldiers, but sometimes even that's not enough. sometimes the innate system needs to call in the heavy artillery. It needs to unleash the air support. And that is the complement system. It's this collection of over 30 different proteins just floating around, dormant in your blood. But when they get activated, they set off a massive chain reaction, this domino-like cascade where each protein activates the next, which activates the next, rapidly amplifying the defensive response into an overwhelming attack. And you know, the real beauty of this system is how efficient it is. As you can see here, there are actually 3 different ways to kick off this cascade. They have different triggers, but it doesn't matter how it starts because they all converge. They all lead to the activation of the exact same incredibly powerful weapons. So what do these weapons actually do? 3 critical things. First, they amplify inflammation, making that alarm bell even louder. Second, they perform something called opsonization, which is a really fancy way of saying they coat invaders with tags that basically scream, "Eat me," to those phagocytes we talked about. And third, the most dramatic effect of all, lysis, the direct destruction of the enemy's cell. So how does it directly destroy them? By building this. This incredible structure is called the Membrane Attack Complex, or MAC. And believe me, it is just as awesome as it sounds. It is the ultimate weapon of the complement system. Just look at this. This is the final move. The complement proteins assemble themselves right on the surface of an invading bacterium. They form a channel, a literal hole punched right through its membrane. Water and salts rush in, the cell can't handle the pressure, and it just bursts. It's a spectacular and very final end for the invader. Okay, so a system this powerful has to be tightly controlled, right? You can't just have these weapons going off all over the place. So the last part of our story is all about keeping the peace and the serious consequences when that balance is lost. And this is exactly why that balance is so critical. Every single piece of this complicated machine matters. For example, if you're missing a central component like C3, which is key to all 3 activation paths, the result is severe, recurring infections. If you're missing the final pieces that build that membrane attack complex, you become super susceptible to specific bacteria like Neisseria. It really shows you the system is only as strong as its weakest link. Look, this innate system is ancient, it's powerful, and it protects you from countless threats every single second without you ever even knowing it's there. It recognizes broad patterns of danger and reacts instantly. But it has no memory, so it treats every invasion like it's the first time. So the question is, what happens when a truly new enemy shows up? One that's clever enough to evade these first responders? Well, that's when the fortress calls in the special forces. And that is a story for another time.